Hey there, and welcome to assignment number 2 in COG 376, Computer Models of Language, and etc. So, this time, your assignment is going to be to make your own chatbot, right? Something along the lines of our old friend Eliza. To do that, you're going to need to make use of the things we've been doing with regular expressions to make a sort of a model of language of sorts. Hey, looks like we're finally getting there. So what we're going to make is what's called a rule-based model. So this is essentially the system is looking for certain little patterns, like we've done with regular expressions, in the user input, and it's going to then match on those patterns, select an appropriate answer, and potentially extract something to say back from the pattern. And the goal being to make a sort of a useful chatbot. So, or at least one that gives the impression of chatting with us. So, I'm going to open up idle. I'm going to make a new file. And as I've said before, I have a notes file off to the side. I'm going to save this. Hang on, I'll just call it Eliza demo.py. Okay. So, what is the structure of this program? We're going to have a few different things. First, well, before I get going too quickly, you are totally welcome to do this on your own and try to figure it out and play around and build it on your own. This video is meant to be a guide to show you one way to do it and a sort of a guaranteed way to get you to the destination. Now, I don't want you to just, this will be in the assignment write-up when it goes up, but I don't want you to just copy me this time. Copy my methods, and then you can replace all of the matched patterns with other things that you want. So the goal is for you to create your own chatbot that's able to carry on some kind of conversation. It doesn't have to be amazing, don't worry about it, but the idea is that you'll put your own twists into it. So let's scaffold this. One thing that we always have when we're interacting with the users is the main loop here at the bottom. Another thing we might want is a sort of a primary function. So we're going to want to define our own the main function. Now, well, maybe not main, but the central function, right? The thing that's going to do what we want. And then we have a few different structures we can put here. Oh, we'll also need to import a couple of things, imports. And then we also are going to talk about knowledge, data, and overall information, right? So models. Those are really just going to be dictionaries for the most part. But the idea is that is the stuff that the model that we're making, the rule-based model of language, is going to know. The things it's going to be able to, indicate to us. So let's get a couple of things imported first. For one thing, we know we're going to have to import RE because that's our regular expression importer. And we're also going to have to import random because I want to emphasize something like that. So before we keep going, let's set out some of the goals. So in the assignment, you're going to be asked to do a few things. One is, so goal 1 should be able to prompt with a random default message if no match. Okay, that's going to be the first goal. Second goal, goal 2, have some patterns that, I should just speak this before I type it. We're going to want to have some patterns that don't require any harvesting of information. So things that are just like matching on a single keyword that's useful, like hello, right? And then we can have the system speak back to us. Goal 3, you're gonna have to have at least one that so have some patterns that just match on keywords, don't capture. we're going to have at least one pattern or more that uses some captured information. Remember all the subgroup stuff we've been doing. And then goal 4 is have at least, or so, one pattern or more that uses 2 pieces of captured information. Now, what do I mean by all this? So I'm going to actually run a sort of pre-readied version. This is ELIZA. So the first one should be, if I just type gibberish, ELIZA should say something like, that's very interesting. I'm not sure I follow. Could you clarify? Right? So that is the most basic thing. This is ELIZA failing to match anything and saying something to spur me forward. We'll talk about those in a minute. Goal 2 is going to be something like, hello, ELIZA. ELIZA knows the word hello and just responds with, how are you doing? What can I help you with? I can say things like, I was walking my dog on the beach. Why does the fact that you were walking your dog on the beach come to mind now? So we see here that this little segment was captured from the user input, right? And then finally, we can do something along the lines of, all dogs are like, well, I've defined it with just is. So a dog is like a cat. How do you think a dog, one part, and a cat, a different part, are alike? Remember, the goal of ELIZA is to give a facsimile of somebody who's just listening to you. ELIZA is all about the mirroring behavior. It's a strategy in talk therapy to just get people talking about something and continuing to kind of push them. We'll throw a few of these different things in there as we go. So I'm going to leave this. I think I've hard-coded it to say exit means, yeah, okay, good. Okay, so we've imported some things. We're going to deal with the knowledge in a bit, but let's go ahead and get that main loop set up. That's always nice because then we can actually talk to our system. So what do we do with main loops? We always have that done flag. So done is false, not flays, false. I'm going to have it just go ahead and print its greeting to us, the user. Hello, I am ELIZA. Great. And then, as always, while not done, right, we're going to grab the user input, equals input, and then I like to give it a little prompt there to start it. So user input is that. Great. If user input dot lower, this is something we're going to do a lot. Dot lower is to help it. As long as if you're comparing things, as long as you're forcing everything into one case or the other, upper or lower or whatever, it doesn't matter. Just for the sake of the comparison, it helps to make sure things match. So I'll show you in a second. For example, exit, right? So if the user's input is exit and nothing else, then we set the done to true, and we move on with our lives. Otherwise, we're going to do the thing that we want to do. And what is that? We're going to discuss given the user input. Discuss is the name of the function that we will write. So this is our primary loop. Now let me just show you over here. I'm in the normal. So let's see. We need to demonstrate that. So this helps to get rid of capitalization issues. So like hello there is the same, dot lower is the same as hello there, right? If I do that, those are the same, they become the same string. So the idea is that when you need to compare, say, user input, where you're not sure if they're going to be following the rules of typing information in, then you will often need to force things into lowercase to make sure they stay matched. So hello there, dot lower, just to show what it is. Ta-da, hello there. Okay. So we have a main loop. We can go ahead and start mucking around with our discussion function in a bit. So let's start with something simple. So define discuss u in, it's going to take the user input at some point. Now, by default, assuming nothing else happens, so let's see. If, so we're going to define a few variables first. So define some variables that we'll use throughout this function, right? A few things we might want. And these are going to be empty to start, and we will fill them up as we go. So match equals none. There's nothing in the match to start. Subgroup 1 is going to be an empty string. Subgroup 2 is also going to be an empty string. And then the response that we want is going to be empty as well. I'll show you how we are going to get all these in a minute. But for now, let's start with, well, let's break down the steps. What has to happen for this discussion to take place, right? We've defined some variables. That's a good start. We're going to also need to find out if any of our rules match the user input. That's going to be a major step. And then we're going to have two different cases, right? If we do have a match, if, as we know, an if statement will come into play. Otherwise, we don't say something neutral, right? So let's go ahead and define that case. I'm going to do this a little bit fuzzy. So we haven't yet done anything with match, but we can go ahead and set up this if statement because match is set to none. So if match is not none, remember, by the time that we've done this, we're just kind of jumping ahead to something that's a little more solvable right off the bat. So by the time we've done that, if match is not nothing, then we're going to do a whole bunch of stuff. For now, we'll just say print nothing. We'll change that later. Else, right? So the case of if match is nothing, then we're going to have to go find some kind of randomly selected automatic response. What might those be? Well, let's see here. Let me go ahead and write it. Print. So the goal of in discuss is always going to be to print something, right? For now, actually, I just realized I could just print match, and that will help us debug later. So, a couple things. We want to have a set of default phrases, right? So let's go ahead and put up here, and remember, we're going out of order. We're not going top to bottom today, but for good reason. We're building things as we need them. So we know that our imports are going to happen first, right? But we also need to now have some data. So here's some data we can use. Default model equals, and we're going to open, this is just going to be a list. It's not going to need to be a dictionary because we don't have to match anything. This is, in fact, the case that we failed to match, right? So we're just going to have a pile of things that are all equally acceptable, right? We have some things like very interesting. That'll keep you talking, right? I'm not sure I follow. Could you clarify? That's another nice one to get, again, the goal is to get the person who is interacting with this, ostensibly a mental health care tool to keep talking, right? I'm going to drag over some of these. Same pattern, just separating with a comma. I pasted these in. They need to be indented properly, of course. Or actually, I suppose I've already told you that you don't absolutely need to do that. Oh, and actually, I'd like to move them back a bit. Just for cleanliness' sake. Let's do that. I think I can actually use Shift-Tab. Nope, not in idle. Okay, so this is what we're calling our default model. This is the set of things that are all fine to say, as long as nothing else has matched. None of our rules have fired. It's just these default situations. So to select one of these at random, let's go ahead and drag that into here. Default model, just checking with what's in there. Oh, it blew up. Oh, because I didn't spell it correctly. Silly boy. Must do things correctly. Okay, good. We have our list. We have a list of things. So selecting something like this at random, we use our random package that we've imported. So if I say random.choice of the default model, now random.choice is going to take a list. I'm not sure I follow. Ooh, can we do it again? Oh, I've done something wrong. Let me copy just up to there and hope it doesn't explode again. Yeah, okay. Please continue, right? So we have the system that is able to, so the goal of having many things to say is that it doesn't sound just like a robot prompt. It's trying to get us to do things to interact with it a little bit more and in different angles, right? So for your case, whatever you build, these are the kinds of things that they're actually going to do a lot of work, because not everything a user says is going to match one of your specialized rules, right? You're going to have a set of rules that are meaningful for your task and the thing that you're trying to do, but you also want to have a set of default things that are going to get the user talking about something else, for example, if the system can't provide any insight on what's going on. So let's just get this going so that we can talk to it. So we're going to do what we just did here, right? Random.choice. Nope, I keep typing the wrong thing. Choice of the default model. Now, quick recapping while we talk about this. What's happening here? I'm printing. Okay, cool. Random.choice. That is a method that's going to choose one of the strings inside of default model. Default model is defined up here, and thus it's available to use in everything that comes after it, even if it's inside of a function like this. So we're able to look outside the function, go to our big bad default model, and ask it for a random thing to say. So right now, our discuss function is going to take the user input, do literally nothing with it. The match will be defined, and it will not be able to change because we're not going to do any searching yet. And then we're going to just go ahead and print. Because match is none by default, we skip, and we're going to print a random thing. So let's just interact with this. It might blow up. It always does. Okay. Hi, Eliza. So we're getting there. We've gotten ourselves into the loop, right? Hey there, Eliza. What does that suggest to you? Now, you see here, that's just one of the things that it can say, obviously. But this is where we will build from, right? So these default statements are going to happen quite often because your user is going to do things that are going to interact with the system kind of broadly, right? You can't assume they're going to know all the rules that you're going to fire. So think carefully about the default model. Okay, let's do a few more things, right? So we want to start defining our main model. So I'm just going to call this one just model. Now, there's a clever trick that we're doing here today. We've seen how dictionaries are powerful, right? They allow us to name variables within a group of variables. You know, we can do model, and then we could have something like first stuff, right? And then here's all the stuff. What we're going to do in this case is we're actually going to define things that the keys are going to be regular expressions. So there's a little trick that we can do for defining regular expressions to make them very clear. Something I hadn't shown you last time that I've only been reminded of recently. Not every language does this. So little thing, regular expression of. So the R helps to make it clear that the regular expression is going to use escape characters. So I'm going to make a lot of use of our friend, the boundary, right? So we're going to say, if there is a word boundary, we're not necessarily going to define exactly that it's white space or periods or whatever, just word boundaries, right? That's what the B is for. Let's go with word boundary hello, word boundary. That is the first key. We're looking for the user to say the word hello anywhere. And it has to be the whole word. It can't be heliotropics or something misspelled, right? It has to be the word hello is spoken. And this rule is trying to capture everything that we can get in terms of just like a basic interaction that we expect to see from the user. So what do we put in here? Well, here's the structure that I'm going to use here, okay? because we might want to have multiple possible responses for each one of these, we're just going to go ahead and assume all of them have a list. So we're getting into some nesting. Oof, lots of structure here. But in this case, we're not going to do anything special. I know this looks like a lot, but the idea is that here's the key, and then here's the list of things. So thing 1, thing 2, thing 3, right? Now I'm not going to make 3 things for hello. I'm going to make her say exactly 1 thing for hello just to get the ball rolling. So what do we want her to say? Welcome. How are you doing? What can I help you with? Right? We want the bot to pause what it's doing and ask how the user's doing. Now, this is where we're going to start to set up the ability for our system to run in and, oh, that's why it looks so far away. Let's oops, I can't shift tab. Let's just get it a little tighter. Okay. This structure will look a little bit more clean as we keep adding to it. So this regular expression says boundary, so there is a word hello somewhere. Let's go and attempt to run it. So let's make sure it works. So make sure we have import re just to make sure. Okay. So re.search, that's the function we use, right? Now I'm going to do this exact same one. Let me snatch it from our code. And boop. So this is the pattern we're looking for. And then let's say, hello there, Eliza, right? What should happen is this should match, right? Let's find out if it does. Ooh, it didn't. Ooh, dear. Something has gone awry. And actually, that might be my bad. What have I done separately from this? I believe... Oh, I forgot to do the lower casing. So we'll do the same thing. Remember, so I'm defining the regular expressions with lowercase. So I'm going to have to force the user input to be lowercase as well. So the dot lower version of it. If I do this, aha, the match has succeeded. So the word hello has on either side of it a word boundary and a word boundary. This pattern is allowed to match. So now our system can run through and say, ooh, give me the response that I need to spit back out at the user. We're getting into the brain of how Eliza does its job. So how might we run through a list of all of these keys that we're going to write that are essentially the rules, the patterns to match, to grab something out on this end? Let's just do it. So we're going to do a loop, right? Because there might be 10. In fact, let's go ahead and write a second one just so it's a little more clear what's going on. So there's a simple one I like here that was quite good. Oh, for example, name. Same deal. R B name B. So if they say what their name is, and I kind of like this message that Eliza, this is the actual Eliza has this one in it too, more or less. These are slightly different than the originals, but this is strictly anonymous. Don't worry about names. Yeah. So now we have 2 simple rules. These are the, goal 2 have some patterns that match just keywords and they don't capture anything, right? So we have now 2 words. I believe I can do this. Simple patterns. And then we'll have a couple that do capture 1 and one that does capture 2. And then we'll have a little chat bot. Okay, so now we have this model set up. The idea is that we're going to use these regular expressions to match on the user input, and then we're going to select one of the answers to spit back out. So we've already got some buckets set aside, right? We've got the match is ready to be filled if possible. We've got subgroup stuff set up, and we have the response that we want. So some cool stuff on the way. We're gonna have to learn some interesting things. So let's just do the basic one. So remember, this is a dictionary. and it has, right now it has 2 different keys. So if I want to get those keys one at a time and check the user input for each pattern, then we can do our old friend the for loop. For k in model.keys, remember we have to retrieve the list of keys from the model. So now for the duration of the loop, k will be filled with each key in the model up here, right? So let's do this. So if we want to populate match, but we only want to do it once. In fact, if it's already full, we want to leave. We want to skip. So as long as match is empty, if match is none, that's the only time we want to do anything in this loop. So this is a choice. This is sort of making it kind of greedy, right? We need the system to pick one thing at least to decide on. So it could be either the first thing it finds or it could be the last thing it finds. Either way is fine. This is just the way that the consequence of doing it like this. So we're going to run through and we're going to say, hey, did this pattern match? So, or rather, if we, here's the flow. I need to trace it a little bit. So remember, we have an empty match right now. There's nothing in there. We haven't failed to find anything is the default case. As long as that is true, we can keep searching. So we will now, for each k, we're going to check something. So now, as long as match is empty, we'll do this. We're going to set match to equal re.search. Now, remember, what are we doing? The model, what's in the model? The model has for its keys, the regular expressions we want matched, and for its contents, lists of possible responses. So let's do that. Re.search, k, and now remember, I'm going to force everything to lower, so it's okay to do k.lower. So k is the first key as we're going through, and then user in is the thing that we're going to search through. User in.lower. And then, if that succeeds, we want to grab a possible response, right? So if match is not empty, so after we've attempted to assign a new thing to match, if it's not empty, then we're going to go and assign the response. So response up here is going to be another random.choice, right? So random.choice on a single item is just always going to give you that one item. So it's a boring random.choice, but it's nice because that means that if it just so happens that you load a list that only has one thing in it, then it works just fine. Even if, so this code could be pulling out lists that have 10 things in them, but we'll see. So random.choice of model sub k, right? Why is that? What am I doing? Well, remember, k is the key, and model is a dictionary, so we can feed the key into the model. So what is this doing? The whole for loop. For each key in the list of keys available, so for each pattern, right? Actually, I'm going to change that right here and now to make it clearer. Pat, right? So the pattern that we want we're going to go ahead and call it that. So instead of k, I'm going to do pat.lower. And instead of model sub k, we're going to do model sub pat. This is just a taste thing. This is just to keep it clear what things are doing. So as long as we haven't found a match yet, search the text for this pattern. If we get a match, extract the response, right? So this whole process is going to loop through every possible pattern available, and so on, until we get to a point where we have one, we've retrieved one, right? So what do we do with that? Actually, I'm going to make a little more white space because it's just nicer. Recognize that these comments are just for your and my eyes, but it makes our code a little bit more kind of accordion-y up and down, but as long as the indentation is right, get used to that being the same thing. This is very nice because it shows us what the heck is going on at each step, right? So Now, if we found a match, so after this whole thing, after this whole segment, if we've retrieved a match, now we can go and print out the response. For now, we're just going to go ahead and print out the response. We're not going to deal with anything else because we're not doing anything more fancy than just saying, hey, here comes a response. Let's do it. Let's see if Eliza has learned these two things. Ha-ba-la-ba-la-ba. Go on. Okay, good. Goal 1 is achieved. Hello, Eliza. Welcome. How are you doing? What can I do with you? My name is John. This is strictly anonymous. Don't worry about names. Great. It's doing it. It's pattern matching on simple patterns that we can then just throw out an individual phrase. Okay? Wonderful. This is actually pretty great. Now we're going to get more complicated. Of course we are. So, I've shown the way the system works. It's able to do something like, remember what I said, so I was something. I was doing something. Let's make that one. So, remember we always start with the R it's for the sake of the regular expression stuff. So, strings with an R at the beginning is regular expression stuff. Okay, we're going to always want the word boundary. In my experience, that just helps the most. I was. This is the key phrase that this kind of rule is based on. Okay. Now, how do we extract things from regular expressions? Well, in the case of this, we use subgroups, right? So, what do we want this subgroup to be? I guess I don't really need a word boundary at the end because it's going to run through the rest of the text if I do it the way I intend to, which is going to be just this. Anything, any number of times, right? So dot means any character, and asterisk means as many of those, or 0 that I want. That's fine, because the thing is, usually when human beings say, I was, you can then extract the rest of the sentence as the sort of the object or subject. Oh, I always flip those. Either way. So what remains of this sentence is always going to be something of interest to the user, right? So let's make at least one, but let's do a few options to say, hey, I'm going to extract information from this. So I was what? I was blank. I was at home, right? So if I want the system to be able to spit out, I was at home, we need to pause and learn a little bit about the formatting function. Now, last time I showed you in the lecture, I'm going to need to update this actually. So the percent sign notation for formatting stuff, so like %s and %s, and then you do the percent of, and you give it a little tuple of like blah 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 blah, and right, and that should just. Oh shoot! Sorry, Eliza, I didn't mean to spit that in you. Let's exit you. Okay, splah. Okay, so we filled in. Remember, the point of the formatting strings there's a lot of valuable things to it, but the main point is to fill in slots. There's a new way to do this. You can put in brackets for formattable strings. You can put variable names like first and second. That is a string. This is an output pattern that I'm going to format by doing the .format function off of the string. Strings now have this .format function that allows you to insert things by name, which is pretty powerful. So I can say, because first was defined here, I can say first equals this, and then second equals that. So now, whoa, a lot going on. Here's a variable name. Here's a variable name. And then the rest of the string is the things that should be there. So something and something else. We've said first is going to define this, and second is going to be defined as that. When I hit enter, this format will fill in the values from here to here. Okay, this and that. Look at that. Why do we care? This is how we extract information and slot it in. So let's do it. What might we want to say back from a therapy perspective, right? Mirroring. So why does the fact that you were first come to mind now? This is an open-ended question that we want for our user. The idea is to prompt them to think about something. They said something to the therapist, and they are being prompted to continue to think on this thing. So what we've done is we've put a placeholder here first. So now when we go to spit this out, we should probably see if there's anything that we can pull out of the text here. How do we get it? Remember, match objects will carry groups. So let's go screw around with groups again. So if we do have a match, now we're going to have to do some things like extract subgroups. So let's extract the first subgroup and make it useful. If we have a match, right? So this is the case. We've defined some variables. We've gone in search of a pattern match. We know what's going to happen if there is no match, and we can also do what's going to happen if there is a match. So if there is a match, we need to do a couple of things. The very first thing is we're going to check, hey, was there a group match? Was there a subgroup? The way to check that, here we can, let me get a match object. So x equals re.search, b a, what am I doing? So that's the pattern I'm matching. And then the string I'm going to feed it is cababa. Oh, I need to, let's see, cababa. Okay. What the heck am I doing? Why am I doing this gibberish? The point is just to show you that this will match because BABA exists. And what's going to be in the subgroup is this part that has matched, right? So let's do it. So x, just making sure it exists. Great. So x.groups, we can call this function, this method of a match object. There was one group. I can check the length of x.groups. Oops, I didn't have to, I did it wrong because I didn't call the function. I just called the name of the function. You have to actually do the parens, right? So the length of the number of groups in X is 1, the number of subgroups at least, right? So that's what this is referring to. So this match object, if I look in the dir of that matched object, groups is one of the functions, and it helps to extract the information. So how are we going to use this? What we're doing here is we're trying to make sure the system doesn't explode by, oh, hey, you did something that didn't have any subgroups. Now you're trying to extract one of the subgroups. Whoopsie. So we're going to check first. The very first thing we're going to do is if length of match.groups is greater than 0, then, remember, we've set aside a variable for this already, so sub g1 is going to equal match.group sub1. Now this is a function. I showed you before how we can do it with list indexing, but that's a little bit clunky. This is a little bit more clean and clear what we're doing. So we're getting that first subgroup. There's more than 0 groups. There's more than 0 subgroups. So we're at least going to extract that first group. Okay, we've done this. Ta-da, wonderful. Now, how do we slot it right back in? Well, remember, the idea is that we're going to use the .format function. So let's do it. Response, we're still going to print the response, but we're going to print response.format. And what do we have? Well, the way I defined the response up here was the word first is the name of the variable. So the beautiful thing about this is that it doesn't care whether or not something is defined or not. If you feed it something it doesn't need, it'll just throw it away. It doesn't care. So first equals sub g1. What am I doing? We've defined sub g1 as nothing to start. If we get a match, great. If that match has at least one subgroup, we go and we get it. We grab it right out, right? And then from there into the response, we want to use the format function to slot sub g1. Now, again, let's say I get a response that doesn't care, right? Doesn't care about subgroups. That's fine. Dot format just says, oh, you fed me a variable that won't be used. That's okay. So if and when there is a first variable to be used, it will be here to be used. Let me show you what I mean. Oops, I did F4. I should probably do F5 instead. Let me save. What have I done? I've done something terrible. Invalid syntax, probably because I pasted something. Okay, F5. Hello, Eliza. All right, what are we trying to test? We have a few different things to say. Hello. Welcome. How are you doing? Great. Now notice it didn't blow up. I'll demonstrate that in a minute. I was just thinking about my father. Why does the fact that you were just thinking about your father come to mind now? Ooh, we've got a little oddity here. This period is a little bit of junk. I'm still deciding if I want to show you how to clean that up. I think it might be maybe a little thing I'll tack on at the end if we have the time. So, it's working. It's working. It took something from the user. I was beat yesterday. Why does the fact that you were beat yesterday come to mind now? Right? The system, designed to help prompt me to keep talking about stuff, has done something like that. And it's even mirrored something I said to it. Beat yesterday. You were beat yesterday. Okay, why does that come to mind now? Great. Now, I also want to start doing things like showing off how we don't always have to do this exact mirroring. We can be a little more vague sometimes, so we can also have something like, checking my note of what I wanted it to be. Oh yes, were you really? A little more non-committal. So now sometimes when the user says something that is matchable, sometimes the bot will respond more directly with like, oh, you mentioned this thing, tell me more. And sometimes it'll be a little more broad. Oh, were you really? As just a sort of a non-committal way to continue the conversation. These are both good, right? These are both ways to keep the user engaged and on track to doing the thing you're doing. So matching one piece, we'll say subgroup. Okay, so let me show you why, how that format thing will be okay. So let's say I feed the sentence habba gabba, right? Dot format, and I say give it the variable first equals this thing. What's going to happen here? Habba gabba doesn't have anything named first. Should it blow up? No, it just doesn't do anything. This is great. This is the kind of flexibility we need for the kinds of things we're doing here. So let's keep going, and let's add something that is going to help us separate two things. I was starting with this before, is like, right? So comparing two different things. Matching two subgroups. Here we go again. So we're going to do word boundaries as always. Let's see. So any number of something before is like any number of something else. Why will this work? Oops, I forgot to close my quotes. There we go. There's a little space here. Why is this going to work? What's the deal? So this is the idea. So again, we're always thinking about the key phrase, right? Is like. So a dog is like a cat for this person, right? And that's what the kind of responses we're going to give. We want to prompt the user again. We want to get them to think something or say something. So let's do it. How about, what resemblance do you see between placeholder first and placeholder second? Ask the user something and get them to talk, right? And again, I want to keep having a couple of different possible responses. So I had another one defined here. Is like, how do you think first and second are alike? Yes. Oops. Just a little bit more possible human phrasing, right? If they always said the same thing, it would be a little less convincing. So let's make sure this is possible now. We're going to do the same thing. We're going to extract yet another one. So if there's at least 0, if there's more than 0, extract the first one. If there's more than 1, subject 2. We're going to go get the second group, right? We're not going to go any further than that, but you could just do this forever. You know, for any number of responses, you can arrange them however you want. You can extract as many things as you want. I've demonstrated how we can do once and how we can do twice, and now you can do 50 or 1,000. You know, you can scale it up from there. So now we have 2 subgroups. Hopefully they're well defined here, and we're going to now print a response. But what's the difference now? We have 2 possible subgroups, and we have 2 possible labels for those to be slotted back in. So we're going to do second, right? That's what I defined up here. I said the first one's going to be named first every time. The second one's going to be named second. Great. Ooh, and actually, I'm going to show you second, first. Hey, you can reverse them because it doesn't matter. It doesn't matter when or where because they are named. These are the beauty things. So first is going to be sub G1. Second is going to be sub G2. Now, let's see if our friend can dance. I think, well, let's see. All dogs. No, I'm only matching on is here. He is like a butterfly. How do you think a butterfly and he are alike? Hey, it reversed it. Nice. He is like a dancer on the wind. What resemblance do you see between he and a dancer on the wind? Now, he it's a little bit of transform clumsiness. That's another thing that we could possibly fix, but I'm realizing that it's not really key to the issue at hand. What's key is that I've just shown, no, don't save. No, cancel. What's key is that I've shown you how to retrieve multiple subgroups and match them from the user's input. We've done it. This is a very rudimentary model, an ELIZA chatbot. I'm feeling a bit down. I'm not sure I followed. Could you clarify? Now, everything you keep adding to a chatbot like this will make it more robust. We can keep adding rules just forever. You can add any number of things. For example, I have one here. I'm going to start copying them sort of wholesale so that we don't have to spend as much time. For example, therapists often want you to talk about your family. It's part of your life growing up, right? What have I done? Well, I'm matching on my, right? And father, dad, mother, mom, or parents. So remember, this is a group. It's a group, so we are actually extracting something, but we're also saying only certain things will trigger this particular pattern. Father, or dad, or mother, or mom, right? This is the first group. It's the only group in the list, so it's group 1. So now we're only going to use the word first, and we can have a handful of options. Tell me more about your blank. Have your parents had a strong influence on you? We can say this. It looks like we've synthesized some information, haha, even though it's just because I've grouped all these into the, quote, parents one, right? Anything else come to mind about your blank? Let's do it. Let's see it roll. Let's see if it can do the thing. My dad's a real piece of work. Have your parents had a strong influence on you? Hey, that's a good conversational seg by this proto-therapist, this false pseudo-therapist. Let's do a couple more of these kind of things, these kinds of pattern matching on a few words. I'm going to grab 2 at once, adding it more robust. Now, these ones, okay, I'm adding a lot of text, but I hope you're starting to see how they are kind of all the same. So this one, I'm getting a little bit more fancy. I'm saying I'm going to match both I am and I'm and I feel and I'm feeling. So, right, those are all possible triggers for this keyword. They're all options. And then I'm feeling what? Well, in this case, we're dealing with the positive emotions, happy, glad, and pleased. Whereas down here, we're doing a similar match, but we're matching on sad, depressed, and burnt out. Here I say, how have I helped you to be happy? What inspired this sudden positivity? Whereas down here, I'm sorry to hear you are blank. It can hurt to feel blank. So these are ways to keep adding more and more functionality to say, I'm feeling sad, Eliza. It can hurt to feel sad. Don't I know it? I'm not sure I follow. So, it's very easy to go off the rails every time we do this, but this is the idea. I'm gonna, let's see. Nothing else is really needs the attention. Just the few things that we've covered here. Matching a specific group. Now, things to note. This is the first group in this case, so that's the only one that we can use to fill in. And it's only a subset of specific things. It's not matching any old thing, right? Here we have the first group is kind of uninteresting to us. It's just helping us match. So we skip that, and if we're actually going to use something, we use second because that's the one that has actual content that the user might have spoken, right? So that is kind of the long and short of it. This is a chatbot. We could do clean up things. We could do, in fact, I'll do that. I'll throw that in right here at the end. There's a way that we can clean up the user text so that it doesn't have things like Daniel is like Greg, period. What resemblance do you see between Daniel and Greg, period? We don't really want that. We can use a function called strip. So, hello, bang, right? We can use, by default, what strip is going to get rid of is the spaces. Dot strip. We have stripped off the junk on the edges. We can also give it a list of things to strip off. So, for example, if I say, strip this text, get rid of all of the white space, so space, just leave a space in there, but also the exclamation points and question marks, the periods and commas, anything that might be lingering at the end of the string. Aha. So now strip, we've given it a custom command. We can now strip off the exclamation point and all the other stuff just to get the content, just the content that we want. We don't want the punctuation to ride along with it. So let's do that real quick before we sign off. So I'm going to make another variable named punct out here in the outside world. It's going to have space, bang question mark, period, comma, colon, semicolon. I also threw in new line, special character, and tab special character, etc. So where we can use this. Where would we use this? We use it in the subgroup situation. So if sub G1 has something going on, if we're in the case where we actually have retrieved a subgroup, we can now say sub G1 equals itself dot strip using this list of punctuation that we've defined. Punct. And then we can do it the same to sub G2. Equals mat, or no, sub G2 dot strip punct F5. Daniel is like Greg. Aha, the period is gone because we stripped it out. Okay, that's going to do it. This is top to bottom. Not complete, I wouldn't say. We could still add new things and new functions. We could have it ask about dreams. We could have it ask about hopes and desires. We could tell it to have it, scold us for saying sorry too often. Whatever you want in your system, in your model of a conversational agent, you can put it, as long as you can think of the way that the rule must be defined. So get used to screwing around with the regular expression pattern to match. Get used to slotting in pieces of variables from using the format function. And you've kind of got all the pieces that you need to build a chatbot. Now, one last go, top to bottom, just to make it clear. Here were the goals. You should be able to prompt with a random default message if there's no match. Let's just check one more time. Is that happening? Does that evoke any strong emotions? Right. We're going to have some patterns that are going to match just on keywords and they don't capture anything. So we have lots of things like that. Hello, name, etc. Have one pattern that uses some captured information, so at least one piece of captured information. So that's this one. We've slotted in the I was something, and then slotted in the first. And then also you don't always have to use the information, but knowing how is the important piece. And then one that does two, so that we can take two separate things. So in this case, anything is like anything else. Now, when you start to chat with your bot and you start screwing around, in fact, this is why I encourage you to define your main loop first. And again, you can do literally all the same things I have. Really, the only difference would be your model would have different stuff in it. It would match different rules and it would spit out different responses. So you can treat this as a shell that you can use to define your own, but you still have to do it all. So get a good look. The main loop is as we've done it multiple times. We have a done flag, we have a greeting, and then we have, as long as we're not done, we're going to call this discuss function. What's in the discuss function? Do one at a time. So we take the user input, we define a few variables just to set them aside, and then we go and we run through the model and say, hey, for each pattern in the model, does it match? As long as it hasn't already matched before, right? If it does match, based on the results of the re.search function, so that comes out and we run the pattern, lowercase it, just to make sure, lowercase the user input as well, just to make sure, and we're going to see, did we get a match? If we do, we can snatch out the response that we want to use. So let's roll back up and make sure we understand that. So model is, we have a few different patterns, right? They all have different definitions of sets of possible responses. Some of those responses are going to slot in information that we've defined by the groups in the regular expression. And then, good. So this means that when we snatch out one of the responses, we're ready to slot in any new information. So we can continue back in the discuss function. So we've gone through and we've checked to see, did we get a match? Did we get a hit? Is there some way I can respond that's interesting? If I do have a match, so as long as match is not nothing, then check for first subgroup. Check for second subgroup. Okay, so if the number of groups is sufficient, go and get the next group. If that, even more groups, go and get that group, right? Also, we're doing some cleanup. So punctuation to be removed. Good. So we do the cleanup. We get the subgroup 1, we clean it up. Subgroup 2, we clean it up. And then we print, again, using the formatted string, output response with, what's the word here? With user concepts slotted in, right? So response is the text. What might response be at any given time? One of these. So response is going to have one of those in it. And sometimes we're going to want to slot some things in using the format function. So first would be subgroup 1 and second would be subgroup 2. We know what we're doing there. So when we go to print it, it will do all the work for us. The cleaned up subgroup information is now slotted in. Failing all of that, if we have failed to find a match, the system is still going to say something. Say something random from the default model. A set of conversationally encouraging but semantically lightweight phrases to throw at the user to get them to continue to talk. Whereas finally the model is more of the knowledge, the rules for generating responses. And that's it. All of this is only possible, or many parts of it are only possible because we have imported the regular expression package and the random package. And that's it. Top to bottom, import regular expression and random, define a model of rules that we will use to pattern match the user input, define a default set of things to spit out, define some punctuation that we find distasteful, write ourselves a discuss function that will take user input and spit something out, which we've just stepped through in great detail. And then your main loop is the way that we're going to interact with the user by take their input in, do something with it. And also, this is always good to have. You should probably always do something like this. So if the user input is a specific word, you're set done to false and leave. So you don't get stuck in an infinite loop. It's annoying to deal with those sometimes. So that's it. This is one example of a way to write a chatbot the ways we've talked about. And here we are. We're finally knee deep in creating an instantiated model of language. It's a dumb one, but it does a pretty good job of interacting and pretending to be a model, or rather a person trying to help. Now, one last rule I like to throw in, because it's good to be transparent. Where was it? What's it called? I had this one defined before, so I'll throw it in the end here. Robots, stuff about robots, machines, chatbots, computers, right? You can be a little cheeky here at the end. So, hey, they mentioned robot, machine, or chatbot, or computer, or in multiples. Do the capabilities of modern computers worry you? How does my kind relate to your problem? Yes, I am just a machine, but my goal is to help you. So in fact, this is actually well done research on the idea that things should not actually typically try to pretend to be human when they're a model like this, when they are intentionally a model. They should be upfront about the fact that they're artificial so that you don't get this strange feeling of competition and betrayal from humans. Hey, we get weird around uncanny valleys. So if I just run this last bit, run it back. Man, robots are crazy, man. How does my kind relate to your problem? It's a little pithy, but it's doing it. And it does it. It'll talk and talk and talk. It'll tell us to go on and on and on. I am tired. Not sure I follow. I am tired. Go on. Wait, didn't I have... I was tired. Why does the fact that you were tired come to mind now? And exit. And that's it. So I hope this has shown you from start to finish. I'm going to do a slow scroll so you can sort of get a view of each bit. Pause it as you need to if you want to copy some things down. But remember, your goal is going to be to don't just copy this. I mean, you can do something along these lines, but fill in your own stuff here. Show me how you might want to have a chat with a robot. Really, you can do anything, as long as you're at least meeting these capture guidelines that will be in the assignment. So that's it. Thanks so much. We'll scroll down a little more as we go, just to Give that quick look at each piece so you can pause the video and have a look. And we're done. That's it. Thanks so much. Take care.